Hello and good day. Welcome back to our class. This is teacher Onin de Guzman. Our lesson for today is limits by direct evaluation, and this is intended for the calculus of grade 11 classes. In this video, it focuses on how to evaluate defined limits using direct substitution. So let's have number 1. So limit of 5 as x approaches negative 1. So recall that. So the limit of constant is actually that constant. So therefore, the limit of 5 as x approaches negative 1 is equal to positive 5. Next, number 2. The limit of negative x plus 2 as x approaches negative 5 over 2. Using the direct substitution, so we have negative of negative 5 over 2 plus 2. So negative of negative will give us 5 over 2 plus, I can rename 2 as improper fraction. So I can write here as the denominator 1. So meaning to say, to make the common denominator, so 2 divided by 1 times 2 is equal to 4, and copy the same denominator. So I have here 5 plus 4 is 9 over 2. So the limit of negative x plus 2 as x approaches negative 5 over 2 is equal to 9 over 2. So let's have number 3. The limit of x cubed minus x squared minus 4 as x approaches positive 2. So what we're going to do is simply use the direct substitution. So it means that we have, this is equal to 2 cubed minus 2 squared minus 4. So, again, 2 cubed is equal to 8 minus 2 squared is equal to 4 minus 4. Continuing because the process, we have 4 minus 4. So, the answer is equal to 0. Next, on number 4, so the limit of negative x squared all over 2 plus 2x plus 4. Again, using the direct substitution, we can have negative 1 squared all over 2 plus 2 times 1 plus 4. So we have here negative 1 over 2 plus 2 plus 4. I can add here 2 and 4 right away. So I have negative 1 half plus, this is equal to 6. So solving it further, I have here 5 and 1 half, or this is the same as 11 over 2. Let's have number 5. So the limit of negative square root of x plus 3 as x approaches 3. Again, so we can use the direct substitution. So we have negative the square root of 3 plus 3. So again, using the direct substitution, so the limit is equal to the negative square root of 6. Okay. On the other hand, number 6, we had the limit of negative square root of 2x plus 4 as x approaches 3 over 2. Again, using the direct substitution, so we have negative the square root of 2 times 3 over 2 plus 4. So we can have here negative square root of. I can use the factoring method between 2 and 2. So we have 3 plus 4. So finally, we can have negative square root of 7. Let's move on to number 7. So we have limit of negative x minus 4 all over x squared minus 6x plus 8. Again, we will use the direct substitution, so we can have negative 1 minus 4 all over 1 squared minus 6 times 1 plus 8. Okay, simplifying it further, so I have here negative of negative 3 all over 1 squared minus 6 plus 8. So in the numerator, I have negative of negative 3 is equal to 3 all over 1 minus 6 is negative 5 plus 8. So this is the same as 3 all over 3, or this is equal to 1. Okay, let's move on to the next number. So number 8, so we have limit of negative of x minus 3 all over x squared plus 1. So again, we will use the direct substitution of x is equal to 1. So this is equal to negative of 1 minus 3 all over. We have 1 squared plus 1 plus 1. So in the numerator, I have negative of negative 2 all over 1 squared plus 1 plus 1. So I had 2 all over 3. So let us consider item number 9. So we have limit of sine of x as x approaches pi. So by direct substitution, we can say that sine of pi. Again, if we will use our Cartesian plane, okay, so let's draw the Cartesian plane. So this is our y-axis and this is our x-axis. So the measurement of angle is pi, so means here. So the terminal point is actually negative 1, 0 using the unit circle. Now, so it follows that our x is equal to negative 1, y is equal to 0, and since this is a unit circle, our radius is equal to 1. Now, so let's recall, sine theta or sine of an angle is equal to y over r. So it means that sine pi is equal to the value of y is equal to 0 all over 1. So sine pi is equal to 0. Let's have 2 cosine x as x approaches 3 pi over 4. So let's substitute. So we can have here, this is actually 2 cosine 3 pi over 4. Okay, so if we will use the Cartesian plane to locate 3 pi over 4, so this is the terminal side of 3 pi over 4. So this is your angle. Okay, so again, so we come up with a special right triangle such that the measure of this is actually 1 and this leg is also 1. Okay, and this one is actually square root of 2 based on your previous trigonometric class. Okay, so again, if we will recall that the cosine theta is equal to x over r. Okay, now since x is in the second quadrant, so therefore we can say that x is equal to negative 1. So y is equal to 1 also, okay? And r is equal to square root of 2. Okay, so we can substitute down now. So cosine of x over r, so we have 2 times our cosine 3 pi over 4 is equal to x over r, but our x is negative 1 all over square root of 2. But if we will rationalize this one, so we multiply both the numerator and denominator by the square root of 2. So again, so we have 2 times negative 1 is actually negative 2 all over. Okay, I have here square root of 2 times square root of 2 times square root of 2 is equal to 2. So cancel 2 and 2. So the final answer is equal to negative 2. So that's it. So that ends our discussion for today. So don't forget to subscribe on my channel so that you will be notified on my new videos.